Thank you for having me here. Such an honor. My name is Putu Ariyasa, spelled like that. You can call me Ari for short. And I'm from Indonesia. And thanks for calling. I finally get to get out from Asia. Thanks for calling. So currently I work at Telecommunications Indonesia. And today I would like to share our experience in using Kong as our API gateway, and especially the monetization feature that we added to Kong as our API gateway. So Telkom Indonesia is the largest telecommunication provider in Indonesia, and also the largest one of the largest state-owned enterprise in there. It has been around since the colonial age with only telegraph and post as its main service. And now it has become a multinational telecommunication conglomerate with over around 80 subsidiaries in the region. So one of the key to its perseverance is transformation. And of course, in this digital age, where disruption can come from anywhere, transformation is needed than before, more than before. So Telkom tried to become a digital telco company and have formed several strategies. And one of that strategies involved transforming their API. So why transform the API? There are mainly two problems. First is decentralized manner in the API management. So there's a lot of API in telecom, spread among its subsidiaries, its division, even its partner. And each have their own way to manage and serve the API. So this result in redundant capabilities created by the API owners. Even there's an owner that need to build the same capabilities over and over again for each of their API. Then it result in a unstandardized manner in a building and serve the API. Some use SOAP, some use REST with different level of maturity. Some document that API and some even doesn't document their APIs. And then it also makes the API hard to discover. It is highly possible that no one could provide a complete list of APIs that can be served by telecom. And then the second problem is the business process that is required to enable this consumption, usually done in an offline deal. Mostly by meeting face-to-face and sign a contract. This, of course, takes time and also increases barrier. For example, a small teams or a new startup that has yet to acquire legal ability. So Telkom decided to create, to centralize and digitalize the API management in hope that any part of Telkom, be it the division, the subsidiaries, or even its partner, can easily expose their APIs, and at the same time, provide easy self-service access for any interested party that want to consume the API. So how do we solve this problem? At first, we don't even know that API management is a thing. We thought that capabilities like authentication, authorization is something that you build inside the API itself. So mostly at the time, we Googled a lot. And after several research, we find some things to be prepared. The first, of course, the API gateway, to be the central access to the API. The Google results show us some product that we can use here. So it's a check back then. And then web portals. This is for the human part that will do the consumption or exposing the API. And some of the API platform that we found earlier already include some kind of portal. And then monetization. And this was actually the hardest part because most of the time, most of the API gateway that we found did not include this feature. And at most, they leave us with many unanswered questions. So we guess we need to provide it ourselves. And then for further breakdown of this feature that we have to build, first we need a payment gateway. This was to enable consumer of the API to instantly pay the API. And hopefully, luckily, one of our subsidiaries have a service in this. So we can use that. So it's a check. And then the last one is billing. We need to provide a control over the allowed API consumption after the access has been granted to API consumer. We need to make sure that the value that API consumer get from the API invocation is equal as the amount that they paid or the amount that they will pay. So, at first, we thought that we could just count the number of API invocation or use some built-in rate limiting scenario that mostly available in any API gateway. But we then asked ourselves, is API invocation alone enough to represent the value that the API consumer can get? For example, if the invocation result in a faulty response, does it count as a value? But the API invocation or rate limiting already decrease the amount that API invocation that can be used by the consumer for next time, but it will likely have no value. And then we have an example for an API that can send an SMS. There are two operations. The first one is to send the SMS, and the second one is to get the status of that send SMS. And then the current API owner only charges the consumer for how much the SMS is sent. Then, if they request a status, it was free. So if we were to expose this API into our API gateway, we need to do the same. We need to only charge when the SMS is being sent, and not charge when the status endpoint is invoked. We also need to consider a different amount, a different value that API represent. For example, an API can be given to a consumer with different kind of deals. Consumer get price A and then consumer B get price B, something like that. And of course, a different API will have a different value. Sending an SMS will be cheaper than sending a voice message like that. So that's what was uncertain back then. To replace, how do we rate and, if necessary, limit the API call based on their monetary value? This is our requirement back then. And this was uncertain. But despite the uncertainty, we decided to just go straight to the experience to better learn from the experience. We picked one of the open source API gateway, not Kong back then. We haven't met Kong. The reason why we picked this is because it has many features. It includes some portals and also a Swagger definition. So at the same time, we have a way to standardize how we define and document the API. And then we create our own billing service, and we decided to use the matching Swagger operation to give a rate to the API. For example, the invocation that match get SMS will be 0, but the invocation that match post/SMS will be 300, like that. And then we associate an API with multiple plans so that consumer can have a choice to what plan they subscribe. Then we add some kind of wallet to the subscriber for the rate limiting scenario so that every time value was given to the consumer, the wallet will be decreased like that. So how do these two services play together? So we added a handler to the API gateway so that every time a request comes, we send a charge request to the billing. The charge contains several data, such as publisher username, the API version, the subscriber username, the API ID, and the matching Swagger operation. Then our billing will look up the matching rate, then apply some rate limit if it's configured like that. And then if the charge is success, the API gateway can forward the request to the API. But if the charge was failed because limit is reached, something like that, the API gateway will terminate the request. And then on response, if the API invocation is regarded as faulty one, it will send a refund request to recover the amount that was charged before. So does it work? Yeah, it kind of does. And the service are still running currently, but we're going to phase that out. But we found some shortcomings. The first, the API gateway, to have many features for us back then, it was monolithic one. It is hard to extend the API, to extend the business process beyond what defined it in that API gateway. For example, we are stuck with OO2 authentication. We even, it's hard to not use authentication at all. That's is pretty hard back then because it's monolithic. And then that rating mechanism that we defined earlier was insufficient. Of course, the Swagger operation is enough for something so simple. But for something other than complex, it's unfortunately not. For example, the the API that sent SMS earlier, we later realized that the number of SMS that can be sent is more than one. So if the SMS that was sent is 2 or 3, we need to charge twice or thrice the registered amount. And luckily, that how much multiplication that we can do to increase the rate is available on the request data by inspecting certain field in the request data. So the scanner that we first not support is rating based on request data. And then we also have an API to broadcast an SMS to several recipients. The amount to charge should be to the number of SMS that can be delivered to recipients, And that amount can only be found after the operation is complete. So to be able to support this, we need to inspect the response, at least, assuming that the API returns some info or hint about how much the operation, how much the SMS was sent. So the third scanner is based on the response data. And the last, we have an API to send a voice message, but the API is only scheduling the job. The voice will be sent sometime later, even after the response is sent back to the consumer. So the last scanner is based on an asynchronous operation initiated by the API. So based on this, we decided we can go no further with the current setup and try looking for new way to do things. And that's when we find Kong. We love the plugin system. We love how easy to configure Kong. Back then it was 0.11 version, the version of 0.11. And then we love how active the community and how awesome the community is. And that's when we decide to move the API gateway to Kong. Of course, if we move the API gateway to Kong, we need to rebuild everything here. Rebuild the portal, rebuild any supporting components. But at the same time, we have the opportunity to leverage other technology, other supporting technology, especially the open source one that keep advancing this time, and apply some best practice such as microservices, container, and CI/CD for better development process. And of course, the main point is we are able to enhance the billing and integrate it via Kong plugins. And this will be the main point. So first, we enhance the billing. The first thing we do is to enhance something internal, like rewriting the code, choosing a better storage for rate lookup and rate limiting. We use Redis cluster in this case. Then storing time series data of even API invocation event that was recorded. We call it a transaction. And make sure that the service is horizontally scalable. Then the second one we did is we refactored the charge API so that the amount to charge or the rate that is applied can be modified by the consumer of the charge API. This is mainly by passing some arithmetic operator and modification values as replaced by 0, replaced by 1, or add 200 to the current rate, or multiply 2. And this was supposed to be counted by the dependent service, in this case, our API gateway, Kong. And then it is also possible to require this external rate so that if the information is not available, the dependent service can defer the charge until the information is available. And then we add a detachable flag to the rate to signal the dependent service that the charts can be done even after the response is coming for asynchronous operation, some kind of flag like that. And then we add plan level access control. It was not added to the billing side because we have another service for access control, but this is worth pointing because even if we try to transform everything to digital, there's still business process that needs a manual, manual job to do before allowing API consumption. So that's what we do to our billing enhancement. Then of course, we made some plugin. The first plugin we create is just to play nicely with the previous business process that were defined in the previous API gateway. We add publisher name, API version to Kong root. Then we add subscriber username and app ID to consumer. Then we store that data into some certain dictionary under ngx.ctx for later use by other plugin. Then we added a plugin to match what the current operation based on the Swagger data. So APIs, what we call API is equal Kong root with a static path, slash the API name slash the API version. And then after that, the plugin will process the rest of the request URL using radix tree to avoid regex, to match the Swagger operation that is being invoked. At first, we were registering multiple multiple paths to the root to Kong. But if we will define if an API will have many operations, we don't think that it's scalable to do regex match for every API invocation. Then, of course, we store the match in ngx.ctx for later use. Then we added a plugin to dynamically process the request and response data. This was based on a JSON logic, nice project. It's a way to serialize a logic so that it can be sent. We choose this plugin because we choose this language because it is easy enough to port. It's provide a flexible operation, but it is restricted because the API publishing operation will be done by each of the API owner. So we don't want to say let them include some endless loop or something like that. The request will be like that. So in this way, we can inspect the response, we can inspect the request, and we can store something in ngx.tx so that it will be available for the next plugin. And the last plugin is the billing plugin. This was to integrate with our billing service. The billing will, on a request, the billing will extract the previous data that was set by the previous plugin, the metadata, the Swagger operation, and external data, external rate data that might be set by JSON logic or might be another plugin. And then it will send a charge request. Then based on the response, especially when external rate is required or the rate is detachable, it will add additional data to the upstream service so that the API can know what is the current status of this billing invocation, what is the rate, and so that it can manage how much it should be charged. And then when the response comes, it will either do a refund if it was failed, or charge, because if the previous chart was different because there's no external rate or something like that. So when external rate is available, the plugin will charge the billing as much as the data that is given by the API. This was to overcome the rate that is to be computed by a request or response data. And then the last one, when some operation is completed, some background operation is completed in the API system, the API can send a charge request to Kong with a GWT that was sent previously by when the request came. So as long as the GWT is valid, the charge can be done. This was to enable asynchronous charge, asynchronous operation charge. So yeah, that's it. That's the plugin that we did built, and it played nicely. And the current look of the product that we built. This is the developer portal. They can see, explore the APIs, and then they can see what is the plan of the APIs. They can subscribe, pay instantly, or and then after they paid, they can try using Swagger UI. And then this, and also if the subscriber has no permission to subscribe, they will say something like contact us first to subscribe, so that any manual business process can be done. And then this was the publisher portal. Every publisher will have their own API, their own backend, their own certificate, their own domain, so that we can support multiple publisher that have each of own data. And also this will feature some statistics, some subscription information, some how many time the API is invoked, how many pay, how many repay the API, and such like that. So that's it, I think. And the conclusion is we found that four scenarios to rate an API invocation. That is based on a Swagger operation, based on the request data, based on the response data, and based on asynchronous operation that can be done later or sometimes. And with Kong plugins, the four rating scanner are now supported in our platform. Thanks for Kong. And thank you very much. Okay, so is there any question? Or is there any time left? No?
You can take some questions if you want to.
Yeah, please.
Sorry.
There's any?
Feel free.
Yeah, thank you. Self-service. There is a registration form that that the consumer can use. Self-service. Yeah. 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 Does our platform support self-service onboarding for the API consumer, and also self-service subscription to the API? And yes, it does. I'm sorry?
Over exceed his quota limit. So yeah, like there can be overuses of APIs, right?
Yeah.
So you keep on charging, or you block the service. Oh,
We block the service. So there's a wallet, Every time the API is invoked, we decrease that wallet if there is a rate limit, of course. But if there's no rate limit, then we just store how much they use and we'll later demand payment.
okay, so don't you think it's a little over aggressive for like let's say that API being used in
Yeah.
some mass
Yeah.
like
Yeah, currently it's maybe like that, but sometimes the plan that is the subservice plan that is available is only for a small amount of API. Example like 100 SMS or 10,000, which is less than maybe 10 million rupiah. That be less than $100, things like that.
So you ever thought of using credit system actually?
Credit system?
Like-
No, not yet, not
Okay.
yet. So, yeah. Yeah.
Since this is a great example of like a critical function custom plugin deployed to production, I was just kind of thinking about how do you guys submit, deploy, and manage this, plugin code? And are you guys running on Docker and Kubernetes or so on and so forth? Just sort of like, what is the life cycle like for how a change to this goes to production?
Yeah, so we are still using the previous infrastructure that we used in previous API gateway, and that is a virtualized machine. But each service is deployed in a container system. And when we develop a COM plugin, we create a repository to install all that COM plugin and then package in one Docker. And then to deploy that, of course, there's a CI/CD system. We use open source one, Drone. And then after the Docker image is produced, we just run a Terraform to deploy that to virtual machine, so that still manual, of course manual, but it's still enough, I think. Because there's so many that our service that is stateful, Database, we have 5 databases there, so we can't really, I don't know how to do it in automated platforms such as Kubernetes. So we still use VM, but we use Docker, and we use infrastructure as a code to deploy it. Yeah. Thank you. Thank you very much.